Good day and welcome. Now we're starting with numbers and patterns. This is just the introductory lesson. Take note, patterns are extremely important. In psychology, we use patterns to identify and classify people according to behavior. If we go further, in the stock exchange, we use what we refer to as graphs, and we interpret the graphs to see whether it would be wise to invest or not invest, or buy certain stocks and sell it. In antiviruses, when we write antiviruses, we use patterns to identify viruses. Normally have something common about it. So antivirus just identifies if there's a pattern and that certain amount of numbers appear certain time, then we take that out and we use that to write. I can go on. There's an endless possibility. That what you need to know basically is algebra in itself as a tool is about recognizing patterns to how we solve problems, patterns that have appeared over and over. That is how all these problems were created, and later on you will use this constructively to become better. Now a sequence, as you can see, is a set of quantities, term 1, term 2, term 3, stated in a definitive or definite order, and each term formed according to a fixed pattern. Alright, Tn equal Fn. Virtual terms can then be obtained by substituting, so that n, 1, 2, 3 in the general term Tn. So give you example, term 1, that 1, n becomes 1, represents first term. 2, second term, Tn represents the n term, normally equation representing a sequence. Just example, if you consider a sequence 1, 4, 3, 10, term 1 is 1, term 2 is 4, Tn, formula that governs that is 3n plus 2. You should see there why we call it a sequence or pattern. 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 gives me 10. Now here, arithmetic sequence will also later on develop and look at geometric sequences. Arithmetic sequence is a sequence in which the difference between any two consecutive terms is some constant t. So you see there my constant t was 3. 1 plus 3, 4 plus 3, 7 plus 3. So for the arithmetic sequence we can say term n plus 1 equal term n plus t. So if that was term 1, to get to term 2, I'm going to say term 1 plus my constant difference d. Or stated differently, I can say t equals tn plus 1 minus tn, or simply put term 2 minus term 1. Arithmetic sequence can also be defined as a, then my second term would be a plus the difference, my third term would be a plus my 2 times my difference, as you can see there from a, and then my fourth term a plus 3d. So term 4, 1 less, term 3, 1 less, term 1, etc. A is referred to as the value of the first term. T is a common difference and is obtained, as I said, term 2 minus term 1, or term 3 minus term 2, or Tn minus Tn minus 1. Value of the n term, Tn equal Tn plus c. N is the position of a term and can only be a natural number. Therefore, it's always positive and not equal to 0. So n is not allowed to be negative. Right, linear patterns. We refer to them as linear because when we draw them, they simply form one continuous straight line. Right, arithmetic sequence is the first common difference between consecutive terms. So if you look there, 1, 5, 9, and 13, a is 1, or I can say term 1 is 1. D, term 2 minus term 1, 5 minus 1 is 4. Term 3 minus term 2, 9 minus 5 gives me 4. Or D, term 4 minus term 3, 13 minus 9 gives me 4. Alright, so that's just a basic introduction to number patterns. As I said, number patterns we even use in hardware when we have to program it so that it can arrange whatever you type in order. Those of you who are using Excel and you rearrange and you want a column to arrange from highest to lowest, etc., all those functionalities, we use sequences and series or numbers and patterns, right? And we are then able to program it. All the best. I hope you enjoy the lessons that follow. Bye.